This brief podcast will talk about the pancreas. The pancreas is the second largest digestive gland in the body. It's retroperitoneal. It's a mixed exocrine and endocrine gland. It's similar to some of the major salivary glands in that it's a compound tubulo-acinar gland. The acinar cell is the prototypical secretory cell. It performs exocrine function to secrete digestive enzymes. The centroacinar cells, which are shown like this, contribute to the intercalated duct. They have an exocrine function as well, in that they secrete a bicarbonate-rich fluid. So these would be the centroacinar cells. Here we would see the typical acinar cell secreting its product into a canoniculus. This is collected by the intercalated ducts, and then these just drain into the larger intralobular and pancreatic ducts. The cartoon here would show islet cells. There are several types of islet cells, and these function as secreting hormones. So they are the endocrine secreting cells in the pancreas. This histological view just shows some of the acinar cells with the intercalated duct and the centroacinar cells. The centroacinar cells make up the smallest divisions of the intercalated ducts. The acinar cells have typical basal nuclei, a perinuclear Golgi apparatus, abundant rough ER. They show zymogen granules that are held for regulated secretion in the pancreas. They're secreted when the pancreas is stimulated by secretin, which is synthesized by S cells in the GI tract, and by cholecystokinin, which is synthesized and secreted by I cells in the GI tract. So clearly the zymogen granules, since they're released by regulated secretion, are going to be forming with clathrin-coated vesicles. Basal secretion of the pancreas occurs by input from the vagus nerve. There may be regulated secretion that's stimulated by hormones. Secretin causes centroacinar cells and cells of the intercalated duct to secrete an enzyme pore, but bicarbonate-rich fluid that will neutralize chyme. And as we said, cholecystokinin causes the acinar cells to release their zymogens. There are no striated ducts in the pancreas. Unlike the salivary glands, which have striated ducts to concentrate their secretion, that is not necessary in the pancreas. The pancreatic enzymes that are stored in the zymogen granules are released directly into the duodenum, so there are no striated ducts in the pancreas. Brief review of the pancreatic acinar cell. It's the prototypical protein secretory cell. It's polarized for secretion, so there's basal basophilia with apical acidophilia. There's an extensive rough ER, there's Golgi, there's secretory vesicles, regulated secretion by clathrin-coated vesicles, and membrane will be recycled because of COMP1-coated vesicles. Because there's so much secretion in the acinar cell, there's going to be a substantial amount of membrane recycling. Zymogen granules contain pancreatic enzymes like amylases, lipases, RNases, and DNases, and pancreatic proenzymes like trypsin, chymotrypsin, carboxypeptidase, elastase. And you talked about some of the function of these enzymes in your biochemistry course. The islet cells are endocrine cells in the pancreas. There are several types of islet cells. The islets are scattered throughout the organ. They make up maybe about 1 to 2% of the total mass of the pancreas. As shown in this image, there's a rich capillary network associated with the islet cells. The islet cells may be innervated by autonomic nerves. There are actually thought to be modified Schwann cells that may actually envelop clusters of islets. And some of these modified Schwann cells might be shown like this around the periphery of this islet. There are, as I said, a variety of cell types in the pancreatic islet cells. You need to understand these. So the beta cell, which makes up the majority of the islet cells, synthesizes and secretes insulin, which is involved in a decrease in blood sugar. The beta cell works antagonistically to the alpha cell, which synthesizes and secretes glucagon, which results in an increase in blood sugar. There are delta cells, which secrete somatostatin. F cells are pancreatic polypeptide cells cells, PP cells, which secrete pancreatic polypeptide. There are cells that secrete vasointestinal active peptide, and there are cells that secrete secretin. For our course, I'm not so concerned that you know what the cytoplasmic staining characteristics of the different islet cells are, nor do you need to know much about the fine structure of the granules. I would like you to know that the beta cells secrete insulin, the alpha cells secrete glucagon, delta cells secrete somatostatin, F cells secrete pancreatic polypeptide, EC cells secrete secretin, motilin, substance P. It is very important that you understand what these various hormones do. Not so much for our course, but you're going to need to understand them for physiology, and you're clearly going to need to understand them for pharmacology, because just like in the GI system where there are a lot of enteroendocrine cells, a lot of pharmacotherapy can affect some of the cells in the pancreatic islets. This is just a low-power histological view of the pancreas, so some lobes like this, pancreatic islet cells here, another cluster of islets here, cluster of islets here, some large blood vessels, probably artery and vein within some connective tissue, and maybe some pancreatic ducts shown here and here. Higher power view, some connective tissue surrounding the pancreatic duct. So the pancreatic duct here is a simple cuboidal epithelium. Here are the acinar cells, and you can clearly see some of the zymogen granules. And here is an example of centroacinar cell. Remember the centroacinar cells making up the smallest divisions of the intercalated ducts. Again, a nice view of the pancreatic acini. So these are groups of acinar cells. I can trace an acinar cell like this. I can trace another one like this. Another one perhaps like that. These last two that I traced clearly show the nucleus in the plane of section. No question that you can see some intercalated ducts like this. Here's a cell that's probably a centroacinar cell making up smallest divisions of these intercalated ducts. And look, you can even see some blood capillaries. And you can clearly see the zymogen granules in these acinar cells. Just the diagrammatic view of the pancreatic acinus showing the individual acinar cells. I like this particular drawing because it's showing these apical canoniculi into which the acinar cells are releasing their zymogen granules, and it gives you the impression that these granules are going to be collected into the intercalated ducts. This is an H and E stain to show the basal basophilia and the apical acidophilia in these very active protein-secreting cells in the pancreas. And just a high-power light micrograph. I think I showed you this slide in the podcast on the acinar cell earlier in the course, but you can clearly see the basal nuclei, the zymogen granules, and the clear Golgi complex. And look at all the rough ER in a higher power electron microscopic view of the acinar cell, and here are some of the zymogen granules just waiting for a signal for secretion. And a nice view of some of the clusters of islet cells in amongst the acinar cells. Here you can see intercalated ducts, but you can see the nice islets. You can see rich capillary networks in the islets. And as I suggested, and it's difficult to pick that out on this histological view, but we think these islet cells are actually encapsulated by modified Schwann cells. I haven't showed you this virtual slide box yet, but this is a link to the annotated virtual slide box from the University of Iowa. I think it's useful to look at this. Let me just click to the digestive system, and it shows you a variety of slides. I will click, see if I can find the pancreas, since we've just done that organ. You can click on this. And the advantage of this is you can actually do virtual microscopy on your desktop. It's annotated, so I'm going to click on this button, and it's going to highlight for you interlobular pancreatic ducts, islets of Langerhans. But look at this, I can move around on this image. I can change magnification on this image. So this is a useful site to look at to do histology on your own. You can actually do virtual microscopy with this site. So it's a very good site. It was developed by the National Library of Medicine, and you of course have seen us use this in our lecture presentations.